All right, guys. So you guys should be here by now after this long 3-day weekend. Hopefully, you guys had a enjoyable weekend. You guys got a little rest, and you guys are ready to hit the books running. All right. So we're gonna wrap up chapter 2 by today, and this PowerPoint is gonna be going over sections 2.3 and 2.4. So let's get started. Section 2.3 is going to be covering elements and compounds. So remember, elements are the what are discoverable in matter. They're the simplest form of matter. We got calcium, hydrogen, helium. We'll be going over the elements pretty soon. And compounds are examples such as salt. You guys worked with that in our lab last week. Sugar is a compound. Water that you drink on a daily basis. Those are examples of compounds. So when we're distinguishing between elements and compounds, just remember elements are the simplest forms of matter that are known to man, and they have their independent properties. Like gold, remember, what does it look like? It looks yellow, it looks like gold. It's able to be malleable. We're able to thin it out into thin sheets. If you've seen cooking shows, they have like those, they sometimes like to cook with gold. They put those little gold flakes on top. Those are real pieces of gold. That's what makes those dishes up to like $150 worth of a plate, right? I'm not trying to eat that on a daily basis, but anyways, so that's one of the properties that's of gold and mercury. Remember how mercury used to be used in thermometers. So that's a few of the examples of of elements in its simplest forms. And compounds are that consist of two or more elements. Simple examples are, like I mentioned earlier, salt, sugar, water, and there's going to be other compounds that you're going to be learning pretty soon. But until then, just know these two differences and how to distinguish between an element and a compound. So, matter consists of, remember what I mentioned, chemical and physical properties. 2.1, 2.2 covered the physical properties of matter, whereas from here on out, we're going to be covering the chemical properties of matter. Essentially, what chemical properties mean is how certain substances could form or transform into new substances. Chemical properties typically are identified by the changes that they produce. For example, like a chemical change, it's when it changes from one substance into another substance. So think of chemical reactions. That's a chemical change because we're taking two reactants typically, or one reactant, and we're transforming it by means of a chemical synthesis or a physical change or a chemical change, and we're making it into something new. So that's what you want to look at when you're thinking about chemical changes or chemical properties. We'll go over this a little bit in the future. So maybe something that you guys might need to practice is distinguishing between pure substances or substances in general and mixtures. Remember, in mixtures, we have homogeneous and heterogeneous mixtures, whereas substances, we could have like a pure substance such as sugar, right? Sugar is a pure substance because it's uniform throughout, and it's a substance, not a mixture. We're not mixing anything to compose of sugar. We just have one compound. So it's very vital that you guys are capable of deciding whether a sample of matter is a substance or a mixture. To help you guys, you could use their general characteristics to distinguish from mixtures. So if it looks like a mixture, you're able to eliminate that matter from being classified as a substance. So this next slide, I would suggest highly to become familiarized with it. It essentially helps you classify matter into either a mixture or a substance. It's a really great slide. I'd take some time learning it. Might show up in a quiz, maybe not. Heads up. So go ahead and take some time and jotting this down in your notebook. I would highly appreciate it, and I'm pretty sure you guys would appreciate that. Your future self would appreciate you doing this as well. All right, so symbols and formula. So now we're jumping into the nuts and bolts of the this course. Typically, you're going to be seeing a lot of symbols and chemical symbols and chemical formulas. So let's dive right into it. So chemical symbols are used to represent elements. I forgot elements in my PowerPoint. I apologize, but chemical symbols are used to represent elements, whereas chemical formulas are composed of chemical symbols. They're used to represent compounds. So some examples of chemical symbols are iron, lead, calcium, hydrogen, helium, lithium, and etc. So Fe, Pb, Ca, He, Li. Those are all examples of chemical symbols. And some examples of chemical compounds are carbon dioxide, water, ethane, I believe, and pentane. Those are all names of these chemical compounds. You guys will learn these as well. But CO2, H2O, C2, H4, C5, H12, all of those are examples of chemical compounds. Right, let's jump into now section 2.4. This section is going to be covering how certain signs of chemical changes and what's able to be used to distinguish between a physical property and a chemical property. And these chemical reactions will help us identify those. So the next 5 slides, I'd like you guys to be taking notes on your own. These are common signs of a physical change, such as like a production of an odor, change in temperature, change in color, formation of bubbles, and formation of a solid precipitate. Each of these are common signs to look for when trying to distinguish between a chemical or a physical property. So I'd like you guys to take the time to after the ending of this video pretty soon, please take notes on the rest of these slides from 28 to 32, and I believe that's it. If you have any questions, I'll be here. I'll be walking around. Please stop me, and get the ball rolling. Thank you for listening, and have a good day.